This lesson is on isosceles and equilateral triangles. This lesson will teach me to use the properties of isosceles and equilateral triangles to solve problems. First, what do you know about an isosceles triangle? Draw one and label its features. Here's an isosceles triangle. I know that it has two pairs of congruent sides. We refer to these congruent sides as its legs. The side that is not congruent is referred to as its base. The base doesn't have to be at the bottom of the triangle. It's just the side that is not one of the pairs of congruent sides. This angle at the top is referred to as the vertex angle, or in this case, it's down here. The vertex angle is created by the legs. The other thing that I know about isosceles triangles is that these bottom angles are congruent. Those are referred to as base angles, and it's because they touch the base. So even up here, they're still referred to as base angles. A couple of theorems about isosceles triangles. First theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you notice, what's marked is that the sides are congruent. So because these sides are congruent, the angles that are opposite, meaning across, those are congruent. The converse, and if you remember converse is an if-then statement reversed. So it's saying the same thing but backwards. This one says that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So look at what's marked here. What's marked are the base angles, so the sides opposite those base angles are congruent. And the last one doesn't really have a name, but it is important. Whoopsies. So the textbook that I had a couple years ago called it Theorem 4.5. Don't really worry about it as that. It doesn't necessarily have a name, but it says the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. Tons of words. Bisector of the vertex angle means it's cutting the vertex angle in half. So if you have something that is cutting the vertex angle in half, which in this case CD is, so yep, notice the markings. Because those two markings are up there and they both have that little curve, that means that C is being cut in half. It's an isosceles triangle as well, and I can see it by the two markings there. So if I have an isosceles triangle, and if this bisector is cutting the vertex angle in half, then it will be the perpendicular bisector of the base. Okay, perpendicular bisector. Perpendicular bisector means that it's going to be perpendicular, meaning it's creating 90-degree angles. And it also means that it's cutting not only this vertex angle, but also that bottom segment down there. So if the CD is an angle bisector of the vertex, and if you happen to be working with an isosceles, then it's the perpendicular bisector of the base. These are some pictures that I had students do a couple years ago. Side, opposite, and angle says the side of a shape opposite or across from a certain point. So if you think about this angle here, this person did a nice job of illustrating the idea of a cross. I have some students that struggle with seeing that. And then here was another one that I liked, and again, this was from a project a couple years ago. A side opposite an angle, the leg of a triangle that is not connected to the vertex angle. So this student here was referring to this angle. So the side opposite that angle was the only side that wasn't creating the angle. All right, on to some problems. Let's try these. It says find the value of y. Let's see. I see these markings, so I know that if the sides are congruent, then those base angles must be congruent. So this one's 63, so this one must also be 63. We could use the perpendicular bisector theorem that we just worked with. But what I'm seeing, and you can do it multiple different ways, is I know that triangles add up to 180 degrees. So I'm going to work within this larger triangle here. So I know that this bottom one is 63. This bottom one is 63. And because of this single marking, there's really two y's up here. So I'm going to set up that 63 plus 63 plus 2y equals 180 so that I can get the value of y. After I did my calculations, I realized that y is 27. So find the value of y. That y is 27. Explain why each statement is true. If-then statements are always helpful, but let's just work with it as we need to. It says explain why angle W V S is congruent to angle S. Well, if sides are congruent, then the base angles are congruent. So because those sides are congruent, I know that WVS must be congruent to angle S. Next one says, explain why TR, this whole side, is congruent to TS, that whole side. Well, I'm going to look at the markings. This angle down here with this single mark, I repeated the single mark on the other side because I could figure out that they were congruent using the if sides then angles. There's now a single mark at S, and there's also a single mark at R. So I'm going to go backwards and say that if base angles are congruent, then sides are congruent, which is true in this case. This whole long side has to be congruent to the other side because those base angles are congruent. Solve for x. I see base angles are congruent. If base angles are congruent, then I know the sides are congruent. So those two sides are congruent, which means I can go ahead and set those two equal. Assuming I did all my calculations right, double check my math. I got x to be 2. Letter B. Let's see. I see these two sides congruent, so that means that this angle is congruent to that angle. If that's true, then this angle must be 3x. I know that triangles add up to 180 degrees, so I'm going to say 3x plus 3x plus 4x equals 180. When I combine like terms, 3 and 3 is 6, plus 4 is 10, so x ends up being 18. Letter C. This one has all three angles congruent, and this one's actually an equilateral, equiangular triangle, which I'll discuss here in a second. But because these angles are congruent, that means all of these sides are congruent too. If that's the case, then I can set those equal. X equals 10. Last bit. It says mark the diagrams to represent the theorems. So we know the isosceles triangle theorem was the one that said if sides are congruent, then the base angles are congruent. The other theorem, its converse went the other way, saying if the base angles are congruent, then the sides are congruent. Same thing going the other order. The same theorems can be applied to equilateral and equiangular. So let's look at those words for a second. Equilateral, equal meaning equal, lateral meaning sides. So this one is saying if the sides are congruent, they're all congruent, it's equilateral, then the angles are congruent. 1, 2, 3. The last one, equiangular, this one says that if the angles are congruent, 1, 2, 3, then the sides must be congruent. So everything that we know about isosceles can also be applied to equilateral.